Good afternoon, everyone, and thanks organizers for the invitation. The topic of my presentation is need of innovative testing facilities infrastructure for railways and metro sector. So I will be taking you through present ARAI capabilities, next innovative and must-have facilities in Indian context before we conclude. Just brief about ARAI. ARAI has a legacy of more than 58 years in the field of automotive testing and validation. It has an expertise in developing India-specific design validation plans, testing components, subsystems, and complete vehicle using state-of-the-art facilities. Since last decade, ARAI has diversified its services to complete mobility sector. And you will find lot of similarities when it comes to structural integrity, safety, and performance evaluation of automotive components as well as rail and metro components. So we can go through the present ARAI capabilities. So at my structural dynamics lab at ARAI, we are testing bogie frames as per EN 13749 standard. This for both loco as well as metro application. These frames are tested with service loads and exceptional loads under static condition, and we ensure that the stresses observed are well within the acceptable limit. The durability testing is carried out for 10 million cycles. There will be 100% load, 120% and 140% load is there. And that 10 million cycles will ensure the 30 years service life. We carry out a lot of service load data acquisition projects for measuring different parameters and in dynamic condition, actual running conditions. And for example, displacements, strains, temperatures, pressures, acceleration. And this is one of the project where we measured the wheel accelerations by triaxial accelerometer on high-speed train on Delhi-Mumbai-Delhi route continuously. And the data acquired was analyzed, and that data was used for wheel bearing life prediction. So these are the few examples of component testing what we do at our end. Basically the performance and vibrational durability for as per different standards. The large reverberation chamber facility at our NVH department is used for sound absorption analysis of gangways, glass windows, as well as seats. Interior and exterior noise mapping also can be done as per different ISO standards. The bottom picture you will see, this is the noise barriers on the highways and even on metro rails passing through dense residential areas. So these noise barriers are designed and evaluated in our NVH laboratory, and these noise barriers suppress almost 20 decibels noise. The transmission test facility at ARAI can cater up to 500 kilowatt power at each wheel, and this is sufficient enough to test performance and durability of metro drives. The engineering simulation team at ARAI has got all range of software tools to give the simulation related services in all domains: vehicle safety, durability, NVH, CFD, manufacturing, aerodynamics, and so on. And the accuracy of simulation always depends upon what the accuracy of inputs given to the model, and one of the parameter is material properties. And our materials lab help in that area, and they have developed material database of more than 150 material grades, and those data can be used in CAE domain for CAE analysis and live prediction. Let's look at some innovative and must-need facilities for railways and metros. These facilities, the main objective of having these facilities is to reduce product development time as well as validation time. And these methods have been tested and proved, tried and tested in automotive domain, and that can be extended to rail and metro sectors. So one of the first innovative method is hybrid simulation technique. This is the combination of virtual as well as physical physical testing. Here, the example shown here is a validation of a dampers for ride assessment. You can see here all 4 dampers are in physical form, physical mode mounted on a damper test rig, and rest complete vehicle is in virtual mode. The road profile inputs is given at tire contact patch, and the model predicts the suspension displacements, and this suspension displacement is given back to this damper test rig to real-time controllers. After running this test rig, the output of the test rig in terms of load is again fed back through real-time controller to this model at all 4 corners, and the vehicle behavior and the ride properties can be estimated. So such kind of tools are very handy to reduce the number of iterations. One more thing, we can use this technique in developing the primary and secondary dampers for railways and metro applications. The second one, I'm going to talk about the active safety systems. So prevention is better than cure. The accident prevention systems are becoming more popular in these days, like ADAS in automotive field. And similar systems like Kavach, those are being implemented in rail and metros, which will help for the obstacle identification as well as applying the emergency brakes to avoid collision. So there are this motion platforms are available, and the soft targets which are mounted on this motion platform, and these can be used. These mimic actually the real world objects on the road, and these can be used for testing this advanced active safety systems. Here the video shown is the evaluation of emergency braking systems. Let's come to the infrastructure requirements. One of the missing infrastructure in our country is wheel testing and wheel set shaft testing facility. As the speeds of the trains are increasing, it is very much necessary to evaluate wheels for its structural integrity. So there are some resonance machines are available which can test these axles as well as wheels at very high frequency. That can go up to as high as 80 Hertz. And the requirement is of completing 10 million cycles, which can be completed in hardly 1 week's time. The traditional systems will take number of weeks to complete this. So the main advantage again here in this machines is that because of its working principle, they can detect the crack initiation in the component very accurately. Another missing thing is the big environmental chambers. So India has got the diverse environmental conditions, whether it's a cold, hot, humid, and nowadays all metros, all trains are becoming air conditioned. To analyze the heat transfer or HVAC performance, we need a dedicated chamber which can accommodate a complete coach. for testing in controlled as well as repetitive environment. So this is the one of the missing facility as far as India is concerned. One more, last but not the least, the readiness for the cyber security, the digitization. So digitization has made the systems quite efficient, convenient to use, but they are become vulnerable for cyber threats. So the governance, risk management and compliance is necessary for addressing the cyber security. There is one standard IEC 6452 which is specifically for the Indian Railways, or not Indian Railways, this is made for railway application, and it offers the holistic approach that addresses all the vulnerabilities in overall ecosystems from trains to back office. Finally, to conclude, the automotive, metros as well as rail sectors deals with human lives. So ensuring safety and reliability is mandatory. So there is no options for physical testing. Yes, there are, you can reduce the number of iterations by innovative tools. There are also challenges to put up such kind of a testing infrastructure because of huge investment, space requirements as well as skill manpower requirement. But in my opinion, the collaborative as well as consortium approach between all stakeholders can address these challenges, and we can make our country self-sufficient in testing and validation and contribute towards Validate in India initiative. Thank you very much. Please.
Former railway board member, you spoke about rail wheel fatigue testing.
Yes.
So will you be able to give the vertical, lateral and longitudinal loads?
Yeah.
Because for the last 20, 30, 40 years, Indian Railways has been testing its wheels in a very conventional manner. And your ARI, I don't think has come forward in a very big way to help Indian Railways. This is the first time I'm really hearing. Of course, you all have been there in bits and pieces, but never fully this thing with us. So I don't know how you're going to do the fatigue testing of rail wheels at high speeds, say of 180, 200, because I've seen that personally myself being done in a few labs across the world. Not very many can do it across the entire world. I don't know how you are talking of that.
No. Exactly, I have shown that there are limitations. We don't have such facilities in India, and ARAI is open to collaborate along all the stakeholders to put up such facilities in India. Presently, we are doing the axle test only by vertical bending mode, but there is this what machine I have shown is basically for the torsional.
So this is what
Yes.
you will work on. Thank you.
Thank you so much, sir, for your insightful words. Now I would like to request Mr. Vinod, sir, to please provide a token of gratitude to Dr. Amudan Valavan, sir. I request sir to please grace us with his presence. I would like to request Vinod, sir, to please provide a token of gratitude to Mr. Vikram Shinde, sir. Can we please have a big round of applause, everyone? I request Vinod sir to please provide a token of gratitude to Mr. Dr. Amudan Valavan, sir.